Now we look at the second term associated with the wave propagation, that is frequency. Whenever you consider a wave, so whenever you are considering a wave, here is the wave, let us suppose, and in this wave, if the propagation is going like this, the wave is moving in this manner, this is the propagation, and compressions and rarefactions are produced like this. These are the alternate compressions and rarefactions, and this is how the propagation is going, propagation. Now, here, if at all, it is making number of vibrations. This is the time taken. Let us suppose in 1 second, these many waves are produced. So, here to here, this is 1 wave, 2 waves and 3 waves. That means 3 waves are produced in 1 second. Therefore, frequency can be defined as number of oscillations per second. This is the definition of a frequency. Here in this example, so I can write frequency as, mathematically I can write frequency is number of oscillations divided by time taken, total time taken for these oscillations. So here its unit coming out to be, units for frequency are coming out to be number of oscillations per second. Number of oscillations has no unit because it's a number divided by time, that is second. Therefore, you can call it as second inverse. Second inverse. Second inverse is the number of oscillations. One oscillation in 1 second is going to be 1 Hertz, or otherwise you can directly take number of oscillations per second as the unit, number of oscillations per second, and in SI system the same thing, units are number of oscillations per second. The same thing in SI system you call as Hertz. So in the above figure, here the frequency of this wave is going to be, from here to here the time is 1 second and 3 oscillations are produced. In the above figure, the frequency of wave can be written as 3 Hertz. 3 Hertz. That is the frequency, because it is making 3 oscillations per second. In 1 second it is making 3 oscillations. So here it is 3 Hertz. So you can take Hertz as the unit, which is nothing but number of oscillations per second. So frequency can be defined as how many oscillations a wave makes in unit time. That is how the frequency can be defined. Then comes the third definition we have to look at is amplitude. Third definition we are going to look at is amplitude. Amplitude denoted by A. The representation is A, and frequency can be represented by either F or N. Small f or n. This is the notation for frequency, and here this is the notation for amplitude. Amplitude is nothing but same thing. Whenever a wave is propagating in this manner, the particles are displaced from their mean positions and reaching to the maximum displacement. So this is the mean position. If I suppose from here they are displaced to the greater extent up to here, and this separation is called as amplitude. So amplitude can be defined as the maximum displacement of a particle, from its mean position. Its mean position during oscillation. So this is the maximum displacement. So here to here it is going. That means whenever you consider the same case in terms of a tuning fork, here when it is vibrating, so this tuning fork is remaining here and prongs are going to this extent and this prong is going to this extent, and from here to here it is called as amplitude. That means this is the mean position, it is going maximum this side. Similarly, when it is coming inward also, when it is coming inward, you will be taking this as, if you have a tuning fork like this, when it is coming inward from mean position, this is taken as minus A and this is taken as plus A, because it is moving along the positive x-axis, it is moving along the negative x-axis. So the maximum displacement the prong can have is this much, and the maximum displacement it can have inward is this much. So this will be represented by minus A and this is represented as plus A. Similarly, the amplitudes can also be for pressures. So there is one more term, pressure amplitude. Pressure amplitude can be defined as, so here when you are taking the y-axis as the displacement, then y-axis as the displacement, x-axis as the time, you are getting the displacement amplitude. Unlike that, if you are taking the pressure on y-axis and the time on x-axis, you will get a pressure amplitude. Pressure amplitude can be defined as the maximum pressure that a particle experiences. So whenever this is pushing the air particles, here the particle will experience a maximum pressure, and then whenever it is coming back, it is relieved out of the pressure. Therefore, the pressure values are increasing and reaches to the maximum just similar to this and comes back to 0, then again increasing in the negative order. That is the reason when you are taking the wave in the form of pressure on y-axis, so you take this as the pressure amplitude, maximum pressure over here, maximum pressure towards the negative side, minus Pm, this is plus Pm, and pressures are measured in pascals, whereas displacements are measured in meters. So these are the amplitudes of a wave. So here we have defined what does it mean by a frequency and what does it mean by an amplitude. So amplitude is measured in meters in case of the displacement, and in case of the pressure it is measured in pascals. So this is how the frequency and amplitude can be defined.